Hello friends, welcome to my channel Study Corner. So today we will discuss about the Ohm's law. It is all about the potential difference and current. It is an important topic. We will discuss about the potential difference in previous video. It would be great idea to watch that video and then come back over here. V is proportional to I, where V is equals to IR. If we remove the proportionality, then the equation is V is equals to IR. George Simon Ohm. He undertook many experiments to develop his theory about the Ohm's law, including measuring the current by touching the live electric circuits to see how much it hurts. As higher the current, more it hurts. Now let's understand by the figure, which is connected with the battery, ammeter, voltmeter, which we already discussed in the last video. The conductor we taken is nothing but a simple wire. Here, the conductor which is we taken, it is nothing but a... Now suppose we connected a 12 volt battery. Then the speed of electrons from here, the speed of the electron from here to positive of a battery's terminal is increases. So the potential difference is increases and created. As we increase the battery's voltage, more electron attracts faster and faster. As electron moves fast, the current moves fast. So if we zoom that particular part, of a wire, we see this flow of electron, which we can see if we zoom that particular part. Now suppose first we connected here the 6 volt battery. So the positive charges is more. Therefore electrons from here attracts towards the battery's positive terminal is faster. Now suppose in case we changes it by 12 volt. Suppose we connected here 12 volt battery, then the speed of electron increases. So the potential difference is created. As we increase the battery's voltage more, here we change 6 volt to 12 volt. Then as we increase the battery's voltage more, electrons attracts faster and faster. If we increase the voltage, then electrons from here attracts faster and faster. As electron moves fast, then current is also moves fast. But it is in opposite direction. Now let's see the definition. The potential difference V, which is represented by V, across the end of a given metallic wire in an electric circuit is directly proportional to the current flowing through it. Again, the potential difference across the end of a given metallic wire in an electric circuit is directly proportional to the current flowing through it, provided its temperature remains the same. Here, the last term is important, provided its temperature remains the same, which means the temperature of a wire remains the same, not changing by more or less. The wire doesn't get heat up. So the wire we have taken should not get heat up. So the equation is V is proportional to I. If we remove the proportionality, then the equation is V is equals to IR, where R is a constant and is called the resistance. It is the property of a conductor to resist the flow of charges. Here the resistance R is the property of a conductor to resist the flow of charges. The flow of charges through it. The SI unit is is represented by the Greek letter ohm. The symbol of the ohm is this, which is a Greek letter. Now, the directly proportional means when the potential difference V is increases, then the current I is increases, and the potential difference V is decreases, then the current I must be decreases. So how to check any material obeys Ohm's law practically? If we take a winding of a wire, and if we apply the potential difference across the end of that, suppose this both ends, if we apply the potential difference across the end of that, the potential difference across the end of this wire is V. The potential difference across the end of this wire is V. Because of this, the current is starting in the winding of this wire is I. Then Ohm's law says V is equals to I into R. Then the Ohm's law says V is equals to I into R, where R represents the resistance that the material offers to the flow of charges, through that material. So the question is, if we have some material with us, then how do we check practically that Ohm's law is obeys or not? For this, first understand the resistance. Resistance is the property of a material and its dimension. The resistance is a property of the material and its dimension. It does not depend on the voltage and current. I. So, if we plot a graph of the values of a voltage along the y-axis and the values of the current along x-axis, here V divided by I is equals to R, which is to check whether the material follows Ohm's law. We need to check whether the ratio of a voltage and current, through that material is constant or not. Let's understand by the figure. Let's take this example of a graph. If Ohm's law is valid, then if we double the voltage, here 2 volts. Now suppose if we double the voltage, let's make 4 volt. Then the current must get doubled. Here it is 2 ampere. So this straight line must passes through the origin, because when the voltage is 0, then current must be 0. And if we connect these points, we get a straight line passing through the origin. Then we says that the material follows Ohm's law. So practically it is not a perfect straight line, but something like this. As we can see in the figure, practically it is not a perfect straight line, but something like this. If this kind of a points we get and plot a graph, then we can say that it obeys the Ohm's law. This kind of a figure is we get because some instrumental errors in taking the observation, and many errors. But if the graph is something like this, then clearly the material does not obey Ohm's law. Here, as we can see the curve in the figure, so it is not obeying the Ohm's law. From voltage versus current graph, for any material, it is a straight line passing through the origin, then that material obeys Ohm's law. So, as the things that obeys Ohm's law, we call them ohmic material or ohmic devices. The material which not obeying the Ohm's law, we call them as non-ohmic material. Let's understand what we learn. The figure is the best example to understand the Ohm's law. As this is the voltage, this is current, and this is the resistance. So, as figure is basically says that more resistance an object has. If any object has a more resistance, the less current that can flow through. If the voltage stays the same, as voltage is trying to push that current, here the voltage is trying to push the current, those electrons through it, and ohm, here the ohm, which is the unit of resistance, is preventing that flow, The more resistance there is, smaller the hole is, the less current you get. You should remember the definition. The potential difference V across the end of a given metallic wire in an electric circuit is directly proportional to the current flowing through it, which means V is proportional to I. And provided its temperature remains the same. This is called the Ohm's law. To remember the formula, we use the triangle. For this is a triangle. Here we take voltage, here current, and here we take a resistance. If you want to find the voltage, hide the voltage and remains term in RHS. So the voltage is equals to current multiplied by resistance. So the equation is V is equals to I into R. Similarly, if you want to find out the current, then hide the current. Then the current is equals to voltage divided by resistance. Similarly, for the resistance, if you want to find out the resistance, then R is equals to, first hide the R, then the resistance is equals to voltage divided by current. And the equation is V is equals to IR, where the V is voltage, I is electric current, and R is the resistance of a conductor. And for the resistance R is equals to voltage divided by current, and it does not depends on the voltage and the current. Therefore, the resistance, the constant at a given temperature for a given resistor. So this is all about Ohm's law. Thank you for watching.